Hey guys, we're going to continue chapter 7 here with section 3 where we're going to be talking about congruent figures. So what you're going to learn today is to identify congruent figures and to use them to solve problems. So let's get going. Here's some vocabulary, so pause and write this down. Congruent polygons are polygons that have the same size and shape. This symbol right here, it's an equal sign with like a little wave thing over it, means is congruent to. When two polygons are congruent, you could slide, flip, or turn one so that it fits exactly on top of the other. Corresponding angles and corresponding sides of congruent polygons are congruent. So here's what the definition is saying. It's saying if I were to flip this one over on top of this one, if I were to flip it over, these things would line up perfectly. In other words, congruent means the exact same shape. They are the same shape. Even though this one looks like it's flipped, or you could say it's slid over and then rotated about, or, different variations of how you could get from here to here, they are the same shape. And when you have that, you get these things that are called corresponding parts. So I have corresponding angles and corresponding sides that are congruent to one another. So notice this angle T and this angle L. They both have a single line right there. That tells us that this angle and this angle are the same. And this has a single dash and this has a single dash. So this side and this side, they are congruent. If this angle's here and this side's here, then that would mean KM is congruent to RY, or TV is congruent to LP. All these different parts are exactly congruent on here. Right here, angle T corresponds to angle L, YV corresponds to MP, R corresponds to K. You would write this is called a correspondence statement, okay, or congruent correspondence, and you would call it a congruent statement is how it's written. So you could write VTRY is congruent to PLKM. I want to point something out, that the order in which you write this is going to be very important. If I'm going to start with V right here, then I have to find the corresponding angle that goes with that, or the corresponding vertex. So V is this one, it corresponds with this. T is here, it corresponds with this. R is this one, it corresponds with this. Y is this one, and M corresponds with that. So it has to be in that exact same order. You could not write VTRY and then LKMP. That changes that congruence correspondence, and it's very important that you have that order correct. Here's a daily funny. So what do you do for a living? I hunt and kill ghosts. That's your job. I've never even seen a ghost. All in a day's work. Look how impressed she is, fellas. You could use this one. This is a nice line right here. I like this one. This is good. All right, so writing congruent statements. Write a congruent statement for the figures. So notice that this shape and this shape, they are the exact same shape. If I took this one and slid it and move it and rotated it around, I could get it to land exactly on top of that. Now what I have to do here is identify where things are exactly the same. So I'm going to take a look at this angle because it's kind of the one acute angle that I have. It looks a little bit different than the others. So I would say that angle R corresponds to angle, it looks like L over here. And then this angle right here, or let's take a look at S. The one that goes from here, this angle, angle S, corresponds to, that's going to be angle K. And then angle T is the one that's up from there. So T corresponds to J, or is congruent to angle J. And then it looks like W is congruent to N. Now what I'm doing here is I'm writing out all of the angles that are congruent to one another. And what that does for you is it sets up that congruence correspondence. So if I write it like this, then this right here is my shape. So I would say that R, S, T, W is congruent to L, K, J, N. And it's going to be very important that these things line up. All right, so here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, here's what I got. You may not have had TRS in this order. You might have had RST or SRT or something like that. That's perfectly fine. just as long as T matches up with K, R matches up with J, and S matches up with L. That is the important part here. All right, so you want to pause and copy this down. Showing triangles are congruent. To demonstrate that two triangles are congruent, show that the following parts of one triangle are congruent to the corresponding parts of the other triangle. And there's three different ways we could do this. If all three sides match up with a congruent side, that's called side, 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 then those triangles are congruent. If I have a side followed by an angle followed by another side, that's shown right here, if that happens, side, angle, side, then that means that those triangles are congruent. Or I could have angle, side, angle. If I have an angle and then I have a side and then I have another angle in order, they have to be next to each other. If I have that, then that shows that those triangles are congruent to one another. And these are the only three ways to do that using, the sides and the angles to show congruence. So you'll want to have all of this copied down. Let's see how we use this. Show that each pair of triangles are congruent. Well, looking at this right here, I know that side, this is how you write this, side TJ is congruent to KD. I know that because they both have these little dashes here. And I know that angle J is congruent to angle D because they both have the single line. And then I know that side BJ is congruent to MD. And so I have a side, angle, side relationship so that I know that these triangles are congruent because of side, angle, side. So I could say that triangle TJB is congruent to KDM, making sure I have that congruence correspondence because of, and then you could just use the acronym SAS, side, angle, side. And that's what we use in geometry to describe that relationship. Take a look at this one right here. C is congruent to D, CY is congruent to DX, and Y is congruent to X. So this means that these two triangles are congruent. I know I'm kind of skipping here, but it's for the sake of time. CYL is congruent to triangle DXN by ASA, angle, side, angle. Here's one for you to try. The answers will be up in 3, 2. All right, here's what I got. XYZ is congruent to PQR by side, side, side. All of these three sides are congruent to one another. Triangle KML is congruent to JML by side, angle, side. So showing that each pair of triangles is congruent. You may want to write out the actual sides that are congruent to one another. When you get up into geometry, you'll have to actually write those things out, and that's part of what's called a geometric proof. But for now, what I'm really concerned about more than anything is that you could recognize that they are congruent based upon these three different things: a side, angle, side, angle, or side, side, side. All right, so I think I got one more here. Yeah, a surveyor drew the picture. A bridge will be built across the river from point A to point B. Show that the two triangles, triangles, are congruent, and then find AB. Well, it looks like angle B is congruent to angle D. And then I know that BC and CDC are both 70 yards. So I'd say BC is congruent because it's the same geometric shape as DC. And then I know that angle ACB and ECD are congruent because they are vertical angles. All right, so angle ACB is congruent to angle ECD. I'm going to write over here that they're vertical. Vertical angles. All right, so here I have, in order, I have an angle, I have this angle, then I have a side, and then I have this angle. that matches up with this angle, side, angle. So I have angle, side, angle. So triangle, you just literally draw a little triangle. That's the geometric sign for that. So triangle ABC is congruent to triangle EDC by angle, side, angle, right? So here I have angle, side, angle in that order. So to find the length of AB, I know that DE is the corresponding parts. AB and ED correspond. ED is 82 yards, so if this is 82 yards, because this is the corresponding side, it must be the same. So AB equals 82 yards because corresponding parts are congruent. When you get into, like high school geometry and you start talking about this, you say corresponding parts are congruent, CPAC. Like that's a rule that you'll write out. So that's why it's 82 yards. So this is a way that you could use some of this geometry stuff to do this. This is an actual kind of engineering type application of this. How far apart are these two things? Well, I could figure some things out using triangles to find that distance. I believe that's it for today. Indeed it is. All right, so I hope you took good notes. I'll see you in class.